collecting the dates into months and years was a lot more straightforward than I thought it would be. So that worked out well.
Good. So you found a workaround then to reclassify into separate columns, or what?
Yeah, it essentially makes a second version of the same data set. Since the store and department are just IDs, those are fixed. And then the sales data can just sum down to a month resolution, I guess. And then the is holidays could be a, well, that one I made just a sum of number of holidays in the month, but it was pretty straightforward.
That's interesting. Do you have that on your machine right now? I mean, if I gave you the ball and let you show the screen, figure out how to do that, would you be able to show me what you're doing specifically?
Yeah, sure thing.
If you mind. Yeah, let me see if I can. I got you. Let's see if I can make you a presenter. Because I haven't played with SQL enough to know exactly things. So I'll be honest, it might be better for me to look at it. I'm a visual guy.
Yeah, no worries.
So let's see. Participant, you are a participant. How the heck did I make you? On your taskbar, does it give you the option to present, like to share your screen?
Yep.
Why don't you try that and see if it'll come up on mine? You don't mind?
Yeah, no worries. Share. We'll stop sharing. Okay.
Okay.
Oh, neat.
Yeah, I see it.
Okay, so what I ended up doing, and it kind of is easiest to see in the multi-correlation because that's the larger set. But for this one, I made a sales data grouped. Basically just group the dates by month and then just assign a store and department field because it's already there. And then I sum the sales into, or sum the weekly sales into just a sales field. And I sum the number of holidays equals true into another one. Just there has to be some sort of variable assigned to that. And it ends up giving me, here we go, a very nice representation of data. The sales numbers got a little higher, so I had to scale those to make it clean.
That's really good. Yeah, the pre-processing and cleanup is a little bit of a different animal than it is from Python.
Oh, yeah. Yeah, I ended up working in sales thousands, and then for the pure just sales to months, just timeline, I ended up making that millions because it was very large numbers.
Nice. Okay.
Yeah, I figured out the R stuff. That was a struggle, but I figured it out. Got to learn some new tools. So then, yeah, when we're all done with lecture stuff, I did have one question about just the phrasing in the deliverable. I think I know what it's asking for, and it's just worded, but it's going well so far. Looking forward to hopefully submitting it tonight.
Nice.
Yeah, the write-up will take the longest, I bet.
It's funny, you can look at something 100 times, and then you'll find it the next day, get up and look at it, and like, oh, why didn't I do X, Y, Z? And
yep, that's kind of what happened here.
And that's funny. When I was writing my final capstone project in graduate school, that happened to me. I was struggling with something. I don't remember specifically what it was, but I remember waking up at like 3 in the morning, middle of the night, and I jumped out of bed, and my wife was like, "Are you okay?" I'm like, yeah, I gotta do something. I ran to the laptop and hammered out some stuff. The inspiration just hits at the weirdest times, and yeah, so it works.
Yep, I've had that happen. I've had that happen many times lately with just right before falling asleep, I come up with an idea. It's like, okay, get the phone out, make a note before I forget this.
Right.
Yep.
It happens, and the closer you get to crunch time, the more often that happens, especially in this industry. For some reason, okay, I teach IT classes and data science, and you people are wired very much the same way. It's like the last 2 weeks of class, there's just this sudden fire of neurons, and I get the questions and the stuff comes through, which is good, but it's like everybody's at once. I'm like, holy crap. So
Yeah.
Yeah. That's good. I'm happy that you found a good resolution there. It's interesting to see what people do because there's usually several ways to do the same thing in programming, whether you're doing R or C or whatever. And I don't know if you are on social media, but in Facebook, there's a couple of good Python pages that people go on with stuff like this, and they'll share it and say, hey, what would you do? And they'll share good ideas. Now, there's a few smart Alex that they'll tell you to hit Alt F4 and stuff like that. But
of course.
For the most part, they're very helpful. And there's about a third of them that are just looking for answers to their homework. But some of them are genuinely curious to try to learn, and it's pretty interesting.
Cool.
So there's lots of good resources out there.
Yeah, I'll have to look into that. Thank you.
Sure thing.
Would you like control of the screen back?
Sure.
Oh.
I guess I better do something. So speaking of R, last
You're breaking up a little bit.
okay. All right, can you see the screen somewhat?
Yep, coming through clear now.
Okay, I don't. All right, so I had some good questions this week. Still some confusion on structure and unstructured data in R. And so I went back to the archives. I don't think we covered this a lot, so I want to go a little bit more in depth. If it helps you, great. If not, I probably already covered that part. But this might be helpful for somebody out there working in R who's not used to it. As you can see, we've talked about it's got a little bit different nomenclature. It's a little bit different animal. It's better with clean visualizations that are easy to produce, but it's not as flexible as Python. But some of its rules and eccentricities are a little bit wonky. So what we'll do is we'll touch again on some trees, and we'll cover structured and unstructured data, and we use available data sets in R or RStudio on our UX uses. So my goal for the users out there is to it's quite simple. I want everybody to be more comfortable using R because that's kind of the theme of today. We use Python probably 90% of the time, but to be fair, to be more well-rounded, you need to be able to do other languages as well. And I don't think there's enough in the homework to really push you on R. So from time to time, I did try to kick some stuff out there that I think is relevant. So what I did was I took the example of using the publicly available library in R. They've got a copy of the types that we're all probably pretty comfortable with or familiar with by now, at least. And instead of running it through R and showing you that in real time, I just copied everything and put it in the presentation because a couple times I've had it freeze up on me, and you can do something on your own 100 times, and then when you get ready to share it online, something happens and the technology bug bites, and it's just it fails miserably. So what I'll do is I'll provide you with the code if you guys want it, play with it. So we'll talk a little bit here about decision tree analysis in R. We did some of that in deliverable 4 or 5. We'll go into it a little bit more here in depth. Decision tree, they are versatile machine learning algorithms that can perform classification and regression. Are powerful algorithms capable of fitting complex data sets. So large numbers, groups of numbers, decision trees is a good way to go. And R is especially good at training and visualize the data. So let's talk a little bit about training and visualization. First thing we do, just like working in Python, we import the clean sample and train the data and test it and make a prediction. This is a simplification, but overall, it's always going to follow that same pattern. We'll measure the performance. So, part of the code is here. It should be pretty easy to get from. Well, it works for me. Math tools. Two columns, and when you do that, you'll glimpse, and we're just looking at those two columns, age and fair. That's the output. And then you set about cleaning the data set. And in cleaning, just like any other data set, you want to get rid of anything that's not a number. And we can also use this section to rename labels. And interestingly, we use mutate in our passenger class as a factor, where it's currently levels 1, 2, 3. You get set labels as upper, middle, and lower. Set it as categorical data. And I never liked the survived 0 or 1. I tend to forget which is which, so I just labeled them no and yes. 0 for no, 1 for yes. I think that's how it's supposed to work. And make sure we set age as numeric and fair as numeric. And that's the output. It's a little cleaner, a little easier to read. So right now, the data is not mixed. So all you're getting is the first set of passengers, the first class passengers. So what we want to do is scramble them. The way we do that is a simple shuffle. So we do a shuffle index. So we shuffle the sample. Set in order. And now when you do the head, you should see a mix. Not first class more. And you set libraries. So you have not set up the DLR library. You haven't installed that. This exercise. And we can start dropping some variables that are not needed. So, yes. X number ticket. Ticket number is actually useless. Number. So you first. Sorry, variables. X and minus. Are useless in your analysis. All right. And here we're at class factor class levels. See we're below class becomes upper, C becomes middle. It's pretty straightforward. And we are renaming 0 1 OS. And we will remove NA observations. And now the output should be cleaner. All right. So before training the test set, common practice has been to split the data 80-20, 80% going to the training of the model and 20% making predictions. You need to create 2 separate data frames. You want to touch the test set until you finished building the model and create a function name. We'll create train test that takes 3 arguments. Create a train and test set. Train the model on the train set and test the prediction on the test set. And then we'll start our part from the console if you haven't installed it already. And the code looks like this. So we create the train. Rest of it. Sorry. So we go. It's true. It's the function. We count the number of rows in the data set. We'll call that in row. Next, we're going to return a row to construct the train set. And then we will select the first row to be whether that row is the end row. What we're doing is setting a conditional test. The condition that's true, then return the train set. Otherwise, return the test set. All right. Next part is the test function and the check dimension. Want to add arguments to the function. And we'll count the number of rows in the set. Return train set. So again, if the condition is true, then it'll return back to the training set. If it's not, to the test set. And that mask data set handle, and it's pretty commonly known set that everybody should have access to all the data, and you don't have to worry about paths and all that stuff. You just call on it on the URL, and I will provide that code for you guys. You'll be able to pull that in. And it's in called those agent fair, but you could really use anything you wanted to. You could use bargain from master class or whatever. Of pre-processing, setting up a training test on a frame, and all how it differs from Python a little bit shorter, but it's less flexible. So that is a very it's a short example, and I don't believe that to go any farther on that. So there's only one person with me today. It's like, so Eric, if you have any questions, we're glad to go into it. But if not, I guess I will call it a short one, and we'll pick this back up on Thursday. The next time we meet, I plan on talking about a time series, but I think one that's going to be a little bit more interesting. So I hope everybody tunes into that one and sticks around. That should be the last one for the week, for the term, actually. So, and I think that, Eric, you're pretty much done with, you're on your last deliverable now, is that right?
That's correct, yep.
Wonderful. All right, well, don't forget to, if you've done all that and answered all the questions on the live sessions, you can declare that you're finished, and then I'll submit your grade. You'll be, once that's done, you'll have that, should have access to it. I think that one other person has to do 6, and one other person's on 7 as well. So we're right there at the home stretch. You guys are doing really well. I've been blessed with a good class this time. Well, I usually am. I usually have a good group. So. Anyway.
I did have a question quick, if that's okay.
Sure, go ahead.
In part 4 of the comprehensive deliverable 7, The second bullet says generate a cluster representation, in parentheses image. Does this just mean make a dendrogram from the hierarchical clustering?
Here and see what I think.
Sounds great. I looked through the rubric and it sounds like that's what it means. I just want to make sure because that's coming up to be the next step here shortly.
All right, so you're talking about number 4 here.
Yes.
So and for okay, yeah, I saw it. Hierarchical clustering model. That's really so you that same method you create your hierarchical model that you did last time. I'm going to use that. I'm going to. I thought I changed that. I think I changed the other one.
Yeah, I was just going to end up learning the scikit-learn again. I got a pattern down for that one that I'm starting to understand.
Yeah, that's good. I've got another commands I could share with you guys. Let's see if I can get that. I'll upload it. There's a template that you guys can use on data pre-processing that's got all the things that you can do in Python, as taking your columns and renaming them and reordering things and getting rid of stuff that doesn't help, and really shortens it a little bit. And I wrote for myself. I write applications that work on my machine, and it does shortcuts. It creates them, and I just copy and paste and drop it into my IDE. Because I'm one of those nerds that spend 2 hours writing a block of code that'll save me, from having to spend 5 minutes writing something. But it's part of being a nerd. But anyway, yeah, I've got that stuff saved up. So I can, that is well. Yeah, I'll just share with you because WebEx is making it hard to pull other stuff up. I've got too much open right now.
Yeah, it's been showing the whiteboard right now. So
yeah, I can't get that to go away. I keep sharing the screen, and that's just lovely. But that's okay. Yeah, you can use scikit-learn. That's fine. You do that, and I think the rest of it is pretty greatest hits of the stuff we've been doing during clustering. In fact, a little bit of this redundant. Leverage the same module they've made. We've already done that. Makes clustering a couple of times. Okay. Just I encourage everybody to keep doing what you're doing. The only thing that I suggest for the class in general, speaking to everybody, is that one thing you can benefit from is commenting your code a little bit more fully, because what I'm seeing is sometimes some really good code and good extensions that I can run on my machine and make it work. However, I want you to pretend when you're writing up these consultations for a client that you want other people to go behind you and be able to perform the same work and understand what you did, because as a developer or a troubleshooter, there's little that's more frustrating than going behind someone else and trying to figure out what in the world they were thinking when they did whatever they did. And even if your code works, it'll help to just preface everything with a hashtag, loading libraries, hashtag, setting up training and test setup, hashtag, whatever you're doing, even if it's just a quick few words. It doesn't have to be a paragraph. You can just describe what you're doing. Those of you who write an actual paper to go along with the code, like a separate PDF file or doc file, that works too. That's good. Some people are just sending me the code. And if you're going to do that, make sure you comment the crap out of it. Comment, let us know what's happening with it, because one of the steps of the rubric is usually includes a detailed description of the code and that kind of thing. So if there's no description, that's a point that comes off. And there's only 4 points possible, so you can't lose a single point. That's by 25% of the grade. It's an easy A. So that should help somebody. Anyway, that's my advice for today. I hope that helps somebody out there. And if there's nothing else, I guess I will call it, and we'll see you guys again on Thursday.
Sounds great. Thank you very much.
Thank you for coming, Eric. We'll see you next time.
See you Thursday. Bye.